To have you today for this session featuring Dave Becker from Mississippi Welder Supply. Dave will be sharing insights into the world of welding cobots, collaborative robots that are transforming welding operations across the industry. Whether you're exploring automation for the first time or looking to optimize your current processes, this webinar will offer valuable perspectives on how cobots can enhance productivity, safety, and precision in manufacturing. And with that, I'll hand it over to Dave.
Thank you. Good morning, everybody, and thanks for joining this morning. I'm honored to be part of this today. So I have a slide presentation. It's pretty wordy, I'm going to be honest, but at the end I'll show you some of the installations that we've done over the past few years here with robots, whether they're the cobot style or the high-speed robotic type applications. So if you have any questions, please let me know, and we'll get going. So first of all, like Anna said, my name is Dave Becker. I'm the Sales and Marketing Manager for MWSCO, Mississippi Welder Supply Company. I've been in the industry for 30 years, and just a quick note, I sold my first robots in 1992. So this has kind of been a part of the welding industry for some time now. So the benefits of robots. Robots offer transformative advantages across industries, economies, and societies by automating tasks, enhancing human capabilities, and driving innovation. One of the ways we're seeing more and more robots is for or robots being used is in situations where it's very labor intensive, or it's not a fun job to do, right? So robots kind of can take care of the dirty work, if you will. Increased efficiencies and productivities are what robots bring. So robots excel repetitive, high volume tasks, allowing for faster production cycles, 24/7 operations without fatigue. This leads to significant productivity gains, such as in manufacturing, where automation can boost output by streamlining processes. In global economies, robots enable larger scale operations and standardized workflows, supporting the demands of modern supply chains. So, and we're not only seeing automation and robots in this, but we're also seeing it with lasers as well now too. Many companies now have what they call lasers that run lights out. So they can program a laser to cut material over the weekends because the laser can now efficiently cut the parts, clean the table, and put a new piece of sheet of metal on and kind of go from there. So we're seeing more and more of this after-hours operations, if you will, in robotics as well. Improve accuracy, quality, and consistency. Unlike humans, robots perform precise actions with minimal errors, reducing the defects and the waste in production. This results in higher quality products from electronics to pharmaceuticals. Their reliability ensures consistent output, which is crucial for industries like the automotive assemblies plants in Detroit and around the world. Cost savings and economic growth. By lowering labor costs for routine work and minimizing material waste, robots reduce overall production expenses, which can translate in lower prices for consumers and broader economic benefits like shared income gains from capital investments. On a societal level, robotics drives economic expansion by cutting costs, increasing output, fostering job creation in tech and maintenance roles while spurring innovation. So one of the ways that we do see this quite a bit is we hear from customers or people in the industry like, hey, the robot's going to take my job. And actually, in what ends up happening in most situations is the robot does perform the tasks a lot faster of welding or whatever that may be. And we're finding that they need more people on the front end loading or on the back end unloading because the robot is moving so fast. So actually robotics, as what we have found, has created more job opportunities. Enhance safety and worker well-being. Robots handle the 4 Ds, and that's what I was talking about before, which is dull work, dirty work, dangerous work, and very difficult tasks. Reducing workplace injuries in hazardous environments like welding or chemical handling. This shifts human workers towards more creative, strategic roles in improving job satisfaction and work-life balance. And like I said, this is where robots can get in and do the dirty work that was not fun for an employee to do in the past. Flexibility and adaptability. Modern robots, especially collaborative and mobile ones, can quickly switch between tasks or environments, enabling agile manufacturing and customization without major retooling. In service sectors, humanoid robots enhance customers' experiences through personalized interactions and boosting satisfaction and loyalty. So we're seeing more and more with cobots doing material handling type stuff as we get further into the age of robots. On a broader societal and environmental impacts, robots contribute to sustainability by optimizing resource use and reducing energy consumption and operations. We see a lot more of robotics in the healthcare, in surgical precision. We're seeing it more in agriculture now in a certain way for planting and stuff, and the right amount of fertilizer as far as that goes, and quality of life globally. While robots displace some routine jobs, their net effect is often positive when paired with reskilling programs. Adoption continues to grow with projections for even a greater integration by the year 2030. We do have one customer of ours, a very large customer, that would like to be, by 2035, wants to be 40% manual welding and 60% robotic welding. They feel that that's where the market is taking them, especially with a lack of finding people that want to still do the welding in this industry, in the manufacturing industry. The word robot is also used in a general sense to mean any machine which mimics the actions of a human. It comes from a Czech word robota, generally translated as forced labor. So that's where you get the word robots from. Most robots are designed for heavy, repetitive manufacturing work. They handle tasks that are difficult, dangerous, or boring to human beings. Robots are designed to do the same thing over and over again. So it's all about repeatability, welding that same joint time and time again. For example, a robot might twist the caps onto a peanut butter jar on an assembly line to teach a robot how to do it, its job. A programmer guides the arm through the motions using a handheld controller, which we call a teach pendant. The robot stores the exact sequence of movements in its memory and does it again and again. So it's all about repeatability, and that's where we see the greatest success in a lot of applications where we put robotic welders in or material handling type stuff. Most robots work in auto assembly lines, building cars. Robots do the work more efficiently than human beings because they are so precise. They always drill in the exact same place every time, and they always tighten bolts with the same amount of force, no matter how many hours they've been working. So like I said, it's all about repeatability. So how robots kind of work. An industrial robot with 6 joints closely resembles a human arm. It has the equivalent of a shoulder, an elbow, and a wrist. Typically, the shoulder is mounted to a stationary base structure rather than a movable body. This type of robot has 6 degrees of freedom, meaning it can pivot in 6 different ways. A human arm, by comparison, has 7 degrees of freedom. A robot's servo motor, and this is kind of what I would call the joint, if you will, often just called the servo motor in robotics, is a compact electromechanical device that provides precise control over angular and linear position, velocity, and acceleration. It's widely used in robots for tasks requiring accurate movement, such as arm joints, grippers, or camera pan tilt mechanisms. So the servo motors are very critical in robots, and you'll see some examples here. I'll show too of how they precisely move the different sections of the robotic arm into place and in the same spot every time. Here's some quick stats on robots as of the end of 2024. Approximately 393,700 industrial robots were operational. Across the U.S. factories, this represents about 3% increase from 2023, when the total stood to about 382,000 units. For context, new installations in 2024 totaled 34,200 units, which was about a 9% decline from the prior year, but still the third highest annual overall in the U.S. We did see a little bit of a slowdown. And when we see a slowdown, is we're not getting quotes or out as much or seeing people that are looking for quotes. And as far as robots or automation, some type of automation goes. However, when those slowdowns start to happen, larger companies will take that opportunity to key up their automation process and make their processes better or more efficient during that slow time. We have seen a considerable increase in 2025 here for MWSCO on robotic cells installations as far as that goes. So we are seeing an increase, but we also believe that a lot of this is being driven by the decrease of available workforce. So key trends, growth over time, the U.S. operational stock has more than doubled in the past decade, driven by sectors like automotive, ag, and fabrication, which accounted for about 40% of 2024's installations, and electrical and electronics. Global comparison, the U.S. ranks third worldwide in operational stock, trailing China with 2.02 million units, and Japan. China installed nearly 9 times as many new robots as the U.S. in 2024. From a regional note, these figures focus on the U.S. Broader Americas. Installations reached 50,100 units in 2024, down 10% year over year. You'll see that a lot of the arms that I'll show you here in the next picture are based over in China or Japan. The companies are. That seems to be the kind of the honey hole or the sweet spot where a lot of these arms are based out of. So here's a few pictures of some different manufacturers of robots. So ABB, Fanuc, Motoman, which is Yaskawa, that is our brand that we do most installations on. You'll see Panasonic. There's also ESAB has one out there. Lincoln works with Fanuc, so that's kind of one and the same. Miller has ATP, and then there's OTC and Kawasaki that are out there as far as robotic arms go. So when you have a robotic arm, you have some other components here that are part of the cell that you'll see. And different components are used in different ways, depending on what you're trying to accomplish, whether you're welding something and what that part looks like, or how you're trying to complete the project in a sense, or load it even. So there's a couple different fixtures. The first one is called a rotating fixture. Or it's also called a Ferris wheel, which you'll see I think I have a couple videos that will work here at the end that you'll get to see a Ferris wheel. So that's the first one, the rotating fixture. The next one over to the right is what I call a headstock tailstock. So basically it's got 2 servo motors on either side of it, and then that basically spins around and moves the parts around. And the reason what it does is welding is more optimal when you can weld in what we call in position. So it's not vertical up or vertical down, it's just a flat horizontal. So that headstock tailstock allows you to put the weld in what we call an in position weld. The next one there to the right is it's a Genesis. I call it a Genesis, but it's a turntable. And basically, so it will weld on one side, and then the screen will protect the operator on the other side, and then he will load the parts in, and then it'll spin around, and then he will unload the part that's been welded. And then while he's unloading and reloading again, it's welding on the other side. There's obviously on the lower left is positioners. Positioners are, you'll see some larger positioners in some pictures that I have that are used that can rotate and move around the part to get them in position for welding. And then right next to that is what we call the teach pendant that I referred to. That's the controller that the programmer will use to program the arm, and number one, to program the arm to weld the part. And then you can also do different things as aligning the torch to a certain degree that you want to point the torch at to do the weld. You will adjust voltage, amperage there, wire feed speed will all be done from that teach pendant right there that you see on the lower right. So 10 years ago, 9 out of 10 robots were being bought by mostly automotive companies, by Ford and GM and so on. Now only about 40% of the robots made are bought by car manufacturers. So here's some typical applications where we're seeing robots being used. Spot welding or resistance welding, which I'll show you in a video, hopefully if everything works out okay. Obviously, arc welding, we see it in plasma cutting. We do see it in plasma welding, which is used actually for equipment in the medical field using for angioplasty. Any type of metal transfer, and what I mean by metal transfer, sometimes it's hard facing or coating of a material, bonding and sealing. Laser welding. Laser welding is becoming more and more popular. We are selling a lot of laser welders as of late, and they are going on and they're going in robot cells as well. Laser cutting, flexible automation, and one that I just saw a few weeks back was brazing, copper pipe. Lincoln Electric has developed a robot that will do brazing for copper pipe. So that's something new there. So robots have advantages and disadvantages. Obviously, the advantages, they are flexible, they are accurate, and they do save space. But the disadvantages, they must be programmed and changed each time when the program changes different products. Most applications require some type of a fixture like we looked at before, and require skilled personnel to be able to do what we call brush ups. Sometimes there's some brush ups that need to be done on programming and stuff. We're finding though that a lot of the guys that or a lot of the people that are good welders make good operators for robots. They know what a good weld looks like. They know what a good weld sounds like, and they're able to use those talents and then be able to program the robot. So it's kind of it's morphosizing into a different area for welders. So here is these are some installations that we have done. This first one is a what we call it's a smaller installation. So basically, if you can tell on the first picture by the left, the robot has two stations here. So it's got a station on the right that's closed up right now, and a station on the left. And what the robot will do is while it's welding over on one side of the station, then the operator can load the other side and not get any arc flash or arc burn as far as that goes. You can kind of see the inside of it on the next picture over to the right there from the inside of the robot in the arm that's there. This particular one is called a tandem arm. This installation took place. I'm trying to remember. I think this was out in Delano, Minnesota. So this basically what happens is the weldment or the fixture is so huge that the arms cannot reach the whole piece, the whole weldment. So basically what it does is they use two arms in that cell to weld all the joints that need to be welded. And then what happens is where you see where it says UW-Stout, that rotates around. That's that Ferris wheel. And you'll kind of get to see that in a video here. I'm going to try to show how that rotates around. But this one is very complex system because it takes coordinated motion with the two robots that are in there, or the two arms that are in there, as far as making sure that they're welding in the, they don't hit. We don't want to have a collision. There's the programming is very unique in a sense, but it when they work, they're fun to watch. This was a large installation that we had. So basically, the on the left is what's called a sky hook, and that's a positioner basically. So that sky hook is holding, I believe it was about 40,000 pound piece, basically that needed to be welded, and it can move around. It can actually rotate 360 all the way around if it needed to. And then what it would do then is the robot arm itself is on a rail system that would move back and forth then to weld the weldment as far as that goes, because it kind of spanned that whole area there when it was mounted on that sky hook there. And then the picture below is just the operator station, the controller, and then what we call the power source, which provides the power for the welder itself. This one here is basically a dual setup. So the first picture that we saw was a very small footprint of a robotic welder. This is on a much larger level. This was in our automation center. So basically, there's two sides there, an A and a B. The A side's on the left side, B side's on the right side. If you look closely, each side has what we call that headstock, tailstock. So the weldment can sit inside of that in there and can weld that up. And like I said before, while one side's welding, then the operator is loading the parts and stuff on the other side. And then once it's completed, it goes to the other side. Then the operator moves over, takes the completed weldment out, and then goes ahead and puts the pieces that need to be welded in. So this is this is where we're talking about before with collaborative robots. Everything I've kind of showed you is what we call high-speed robots. These are cobots, basically that can be used for welding. In this situation, that's what they're doing here is they're welding, putting a weld around the outside diameter of that pipe, as far as that goes. Collaborative cobots, I'm just going to call cobots. We've sold some for material handling. So we've had situations where a customer um, wanted to feed material into a brake press and have it bent, and they were short on help. So what they basically did is the robot would grab the sheet of metal, move it into the brake press, release it, let the brake press do its thing, and then it would go back and pick up the piece of metal, readjust it, and let the brake press, and then release it, let the brake press do it again, and then it would pull it off, and then it would stack it. And I'll take questions here. I just want to show you a couple of things here if I can. So I'll try to do this. So this is the arc world that we were talking about with the Ferris wheel. So you can kind of see there where the twin arms are moving back and forth. The guys that program this, they like to have fun and um, they call it dancing with the arms that they're dancing, I guess. So sometimes they get bored. And then the other one, if I have the other one, here we go. So here's one where we're doing spot welding with the cobot. This is the material handling situation. So it puts it in there, it does the spot weld, then it pulls it out, and it'll do it on the other side here. So, so that's where we're seeing also a lot is with that. Hold on, I need to stop that. So hopefully you saw those okay. So does anybody have any questions that I can try to answer concerning that or with robotics?
So Dave, what are the characteristics of the best installations applications that you've seen? If we're thinking about doing something robotic with welding, what should we be looking for?
So usually, like I said, it's that dirty work, it's that not so fun work. The best we look at cycle times. So how can we take a product and maybe it's got a lot of long welds on it and stuff, or it needs to be adjusted manually. We take a look and we try to improve cycle times. So an example that I can give you maybe that might help is I worked with a customer that was building hydraulic tanks, and they had probably about 12 to 14 hours of weld time into this tank. And there was a lot of welds, a lot of long welds. And then the operator had to adjust, obviously, the tank repeat many times to get it in position. So we took it from 12 to 14 hours, and the robot did it like in an hour and 20 minutes. So that's where it's really successful is when we can reduce the amount of time that our key is to get it out, help the customer get their products out the door faster. That's what's best for them. Does that make sense?
Yes, very much so.
Okay. Thank you for asking.
Dave, I was wondering, so I guess like is there any kind of formal education, people have to go through before becoming like the programming for the welding
Mhm.
machines, or you just take people that were already working on the floor before?
Great question. So what we do is when we sell a robot, we offer, I think it's 20 some hours of education, is what it is. So what we do is it's like I said, we're finding that the people that know what a good weld looks like and what a good weld sounds like, those are the type of people that we're looking for. And then we bring them into our automation center, and then we train them to use that teach pendant that I showed you before.
Mhm.
We show them how to use it. We go over the safety part of it, as far as that goes, because there is safety. These robots move at a very fast pace, and that's something I guess I should have brought up too. Is in a lot of those situations where you saw those robotic where you saw those pictures, there's light curtains in there, and when that light curtain is broken, that robot stops immediately because like I said, they move very fast. So we go over programming, safety, and then just general maintenance of the torch and different things like that. So it's not really nobody needs a 4-year college degree. Not that I'm against. I'm not saying that, but they don't need that, right? We're training people on the floor basically is what we're doing. They're identifying people and doing it that way.
Okay.
Thanks. Great question.
And sorry, I just have another quick one because I
Yeah.
found this very interesting.
Yeah.
What would you say, I guess, is the impact on the industry overall? I mean, I know a lot of people go to trade school for welding and things like that. Is this having any kind of impact on the industry just as a whole?
Yeah, it is. Because I think, well, in twofold, like I said, I think the available workforce has dropped tremendously. And so that's why you're seeing, we see with a lot of our customers that are very busy right now, they have very long lead times because they don't have the people to do this. So now they're coming to us and looking for ways to automate and make things happen faster so they can reduce their lead times, as far as that goes. So the impact is good because I think and I always say I'm going to sound like my grandfather when I say this, but the younger generation is more key in obviously to the automation side of it and the programming of it rather than just grabbing a MIG gun and laying a weld down. So it's kind of that it's almost like gaming to a certain extent. And
Right.
now the impact is even greater because now I was just at a meeting here a couple of weeks ago with Lincoln Electric on their robots, and AI is going to be playing a big part coming up here in robotics because where we were talking about repeatability and that same welding that same joint every time, or doing that same thing every time. AI now is putting cameras, allowing them to put cameras at the end of the MIG guns, and then it's telling back what we call the controller, which is the brains of the robot. Hey, the weld joint is a little bit over this way now, so you need to move a quarter of an inch this way.
Hmm.
So it's kind of starting to feed information back and forth as well as we get further into this. So the future of this is going to be crazy in my mind.
Awesome. All right. Well,
Question?
oh, somebody's got a question here.
I do, sorry. What would you say is the mix between what I would call an old style, very programmable versus the new trace style welding robots as the industry moves forward?
One more time, I didn't quite hear it all. I apologize.
Yeah, sorry. What would you say the mix moving forward is the old style where they have to have intense programming and a lot
Yep.
of inputs versus I've seen a lot of robots out in industry now, welding robots where it's a trace style where they basically just trace and the robot welds
Yep.
right where you trace.
Yeah. Yeah, so that's changing. That's change, and that AI is part of that change too as we move forward. The latest and great. So the way that I've always done it, right, or when I sold that, remember that I said at the beginning, I sold my first robot in '92. It was like you pick the start point, and then you would jog the torch along the whole seam of the weld, right, and then you would go to end point, and then that was it. And now basically Seam Tracker is a program. So all I have to do now is, and we're seeing this with cobot welders too, is I just need to pick the start point, and then I just move the torch over, and then I just hit the end point and say this is where the end of that joint is. And the robot knows then I need to make a direct line then. You don't have to trace it along like you said anymore as far as that goes. The other part that's happening with cobots now too is they're not using teach pendants anymore too. So that's changed because now you can literally just grab the arm and you hit a button basically is what you do that says, hey, I'm in training mode. You hit a button on the arm and now I'm moving the arm freely on the cobot saying start here, end here. And Seam Tracker will then go ahead and do that. So that's where we're kind of evolving to. I can only imagine where we're going to go with AI eventually as far as that goes. But that's kind of what's out there compared to the first robot that I had sold in '92. I hope that answers your question.
Absolutely. Thank you.
You bet.
All right. Well, it looks like we had some pretty good questions there. And if anybody has anything else for Dave, I'll be sending out a follow-up email on the next day or so. And you can reply to that with any questions and I'll get them over to Dave.
And just if they get really technical, our automation person would have been on today, Mark Powers, but he had another commitment. So if it gets very technical, he's always my backup. At the end of the day, I'm still just a sales guy, but like I said, I've been around this for a while to at least somewhat answer questions intelligently. So thank you very much for this opportunity today, and thanks for letting me participate.
Perfect. Well, thank you, Dave, for taking the time today. I think people learned quite a bit, so.
Good. Thank you so much.
Awesome. Well, we'll see everybody next month.